Welcome! I am Teacher M. This tutorial video is focused on finding the derivative of a quadratic function using definition of derivative. If you're interested, stay and watch the entire video. To understand better this topic, I highly recommend to learn first the definition of derivative. You may watch the said topic using the link on the description below. To begin, find the derivative of g of x is equal to x squared. Derivative is equal to limit of g of x plus delta x minus g of x over delta x as delta x approaches 0. Similar to the video on finding the derivative of a linear function, find equivalent of g of x and g of x plus delta x separately. G of x is equal to the given function itself, which is x squared. G of x plus delta x is equal to the square of x plus delta x. Expand the binomial, it is equal to x squared plus 2x delta x plus delta x squared. Substitute it to the definition of derivative. Limit of g of x plus delta x, which is x squared plus 2x delta x plus delta x squared, minus g of x, which is x squared, all over delta x as delta x approaches 0. Remove grouping symbols. Limit of x squared plus 2x delta x plus delta x squared minus x squared all over delta x as delta x approaches 0. Combine similar terms. X squared minus x squared is 0. We have the limit of the remaining terms in numerator, which is 2x delta x plus delta x squared over delta x as delta x approaches 0. Observe that when limit is being applied, the denominator becomes 0, which make the whole term undefined. To solve this, we need to eliminate delta x in denominator. In this example, observe that the numerator is factorable. Both terms have the common term of delta x. Thus, we can take out delta x in each term. Limit of factor out delta x, multiply to 2x plus delta x over delta x as delta x approaches 0. We can now simplify it by dividing the delta x by delta x. And it is equal to the limit of 2x plus delta x. Apply limit property. Limit of 2x as delta x approaches 0 added to limit of delta x as delta x approaches 0. Perform the limit. Limit of 2x as delta x approaches 0 is 2x added to the limit of delta x as delta x approaches 0 is 0. Then, the derivative of our function, which is g of x is equal to x squared, is 2x. G prime of x is equal to 2x is the general derivative of g of x. This means that we can find the slope of the function at any point on it using this derivative. Take for example, what is the slope of the function at x is equal to 1? Before we proceed in solving the slope of the function, let's make it clear the output of a function and output of a derivative. Function is a system of input and output. Input is the x-coordinate or domain, and the output when you substitute the x-coordinate to the function is the y-coordinate or range. Derivative of function is also a function that has input and output. Input is x-coordinate or our domain, and the output is the slope of the function. Thus, the original function gives you the y-coordinate while the derivative gives you the slope of the function. Let's have a clearer and concrete view of the question. Using the graph, this is the point on the curve that we are solving for the slope of the function. To answer this question, let's use derivative of the function to find the slope at the given point. The derivative is 2x. Substitute x-coordinate to the derivative. We have g prime of 1 is equal to the product of 2 and the x-coordinate, which is 1. Get the product, which is 2. Therefore, the slope of the function at x is equal to 1 is 2. In connection to this, find the equation of the tangent line on the function at x is equal to 1. There are ways to find the equation of a line that you learned in your basic algebra. In this example, to find the equation of a line, we will use point-slope form. Point-slope form is y minus the y-coordinate is equal to the slope multiplied to x minus the x-coordinate. In our example, the slope and x-coordinate is known. To use this form, we need y-coordinate. To find y-coordinate, use the original function to solve for it. Substitute 1 to the function. We have g of 1 is equal to the square of 1. Simplify. Then the y-coordinate is 1. Substitute x, y, and slope in the point-slope form. Y minus y-coordinate, which is 1, is equal to the slope, which is 2, multiplied to the difference of x and x-coordinate, which is 1. Distribute 2 to each term of x minus 2. We have y minus 1 is equal to 2x minus 2. Add 1 to both sides of the equation. We have y is equal to 2x minus 1. The slope of a curve at x is equal to 1 is 2. And the equation of the tangent line to it is y is equal to 2x minus 1. To visualize this is the graph of the function and a point at x is equal to 1. As you can see, the y-coordinate is 1 and the slope is 2. The green line is the tangent line to the curve at a specific point on it. Next example, what is the derivative of f of x is equal to 2x squared minus 1? Derivative is equal to the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0. Similar process, find f of x and f of x plus delta x first. F of x is equal to 2x squared minus 1. F of x plus delta x is equal to 2 multiplied to the square of x plus delta x subtracted into 1. Expand the binomial. We have 2 multiplied to x squared plus 2x delta x plus delta x squared subtracted to 1. Distribute 2 to each term of x squared plus 2x delta x plus delta x squared. And it is equal to 2x squared plus 4x delta x plus 2 delta x squared subtracted to 1. Substitute f of x plus delta x and f of x to the equation. It is equal to the limit of f of x plus delta x, which is 2x squared plus 4x delta x plus 2 delta x squared minus 1. Subtract 2f of x, which is 2x squared minus 1 all over delta x as delta x approaches 0. Remove grouping symbols. We have the limit of 2x squared plus 4x delta x plus 2 delta x squared minus 1 minus 2x squared plus 1 over delta x as delta x approaches 0. Combine similar terms. 2x squared minus 2x squared is 0. And negative 1 plus 1 is 0. We have limit of the remaining terms in numerator, which is 4x delta x plus 2 delta x squared over delta x as delta x approaches 0. Similar to the first example, denominator will be 0 when limit is applied. To address this, delta x in denominator should be eliminated. Observe that the numerator can be factored out. Factor the numerator. We have limit of delta x multiplied to 4x plus 2 delta x over delta x as delta x approaches 0. Divide delta x by delta x, which is 1. Get the limit of the remaining terms. Limit of 4x plus 2 delta x as delta x approaches 0. Apply limit properties. Limit of 4x as delta x approaches 0 plus limit of 2 delta x as delta x approaches 0. Get the limit. It is equal to 4x plus the product of 2 and 0, which is 0. Therefore, the derivative of f of x is equal to 2x squared minus 1 is 4x. This derivative, which is 4x, is a general derivative of the function, which we can use to find the slope of a function at any point on the function. To understand it better, find the slope of the function at negative 2, 7. On the graph, this is the point on the curve where we asked to find the slope. Substitute x coordinate to the derivative of the function, which is f prime of x is equal to 4x. F prime of negative 2 is equal to the product of 4 and negative 2. Get the product? Thus, the slope of the function at negative 2, 7 is negative 8. In connection, what is the equation of the tangent line to the function at negative 2, 7? Like in the previous example, use point-slope form. In this example, y and x coordinates and slope are known. Substitute those to the equation. Y minus y coordinate, which is 7, is equal to the slope, which is negative 8, Multiply to the difference of x and x coordinate, which is negative 2. Simplify the right side of the equation. We have y minus 7 is equal to negative 8 times the sum of x and 2. Distribute negative 8 to each term of x plus 2. Y minus 7 is equal to negative 8x minus 16. Then, add 7 to both sides of the equation. Simplify. We have y is equal to negative 8x minus 9. Thus, the tangent line on the function at negative 2, 7 is y is equal to negative 8x minus 9. To make it clearer, this is the graph of the function and a point at negative 2, 7. The green line is the tangent line to the curve at the given point, and it has the slope of negative 8. Last example, find the derivative of h of x is equal to x squared plus 4x plus 2. I encourage you to pause this video and try to find the derivative of the function. To continue, derivative is equal to the limit of h of x plus delta x minus h of x over delta x as delta x approaches 0. Find h of x and h of x plus delta x first. H of x is equal to x squared plus 4x plus 2. H of x plus delta x is equal to the square of x plus delta x plus the product of 4 and x plus delta x plus 2. Expand. Square of x plus delta x is x squared plus 2x delta x plus delta x squared plus the product of 4 and x plus delta x, which is 4x plus 4 delta x and plus 2. Remove grouping symbols. H of x plus delta x is equal to x squared plus 2x delta x squared plus 4 delta x plus 2. Substitute h of x plus delta x and h of x. Limit of h of x plus delta x, which is x squared plus 2x delta x squared plus 4x plus 4 delta x plus 2 minus h of x, which is x squared plus 4x plus 2 all over delta x as delta x approaches 0. Remove grouping symbols. It is equal to the limit of x squared plus 2x delta x plus delta x squared plus 4x plus 4 delta x plus 2 minus x squared minus 4x and minus 2 all over delta x as delta x approaches 0. Combine similar terms. X squared minus x squared is 0. 4x minus 4x is 0. And 2 minus 2 is 0. Then get the limit of the remaining terms. It is equal to the limit of 2x delta x plus delta x squared plus 4 delta x over delta x as delta x approaches 0. Factor out delta x from the terms of numerator. Limit of delta x multiply to 2x plus delta x plus 4 over delta x as delta x approaches 0. Simplify the expression, and it is equal to the limit of 2x plus delta x plus 4. Apply limit properties. limit of 2x as delta x approaches 0 plus limit of delta x as delta x approaches 0 plus limit of 4 as delta x approaches 0. Get the limit of each term, and it is equal to 2x plus 0 plus 4. Simplify. Therefore, the derivative of the function is 2x plus 4. Again, using the derivative, we can calculate the slope of the curve at any point on it. Then find the slope of the function at x is equal to 0. To solve the slope of the function at the given x coordinate, substitute it to the derivative of the function. H prime of 0 is equal to the product of 2 and 0 added to 4. Simplify. Thus, the slope of the function at x is equal to 0 is 4. Continue. What is the equation of the tangent line on the function at x is equal to 0? Again, use point slope form. Find the equation of the tangent line. In this example, only x coordinate and slope are known. To utilize this equation, we need y coordinate. To find the y coordinate, use the original function. Substitute x coordinate on it. Then, h of 0 is equal to square of 0 plus the product of 4 and 0 plus 2. Simplify. Then the y coordinate is equal to 2. Substitute all values on point slope form. Y minus y coordinate, which is 2, is equal to the slope, which is 4, multiplied to x minus the x coordinate, which is 0. Distribute 4 to each term of x minus 0. We have y minus 2 is equal to 4x minus still 0. Add 2 to both sides of the equation, and we have y is equal to 4x plus 2. This is now the tangent line on the function at x is equal to 0. To illustrate it, this is the graph of the function. A point at x is equal to 0 and tangent line to it. There you have it. Finding the derivative of a quadratic function. Next videos emphasize the derivative of other functions. If you learned on this video, don't forget to hit the like button and subscribe to be updated and notified for other math lessons. See you!